about the storage area network in computer science and engineering. Moving to the next topic, that is RAID 6. RAID 6 works the same way as a RAID 5 except that RAID 6 includes a second priority element to enable a survival if two disk failures occurs in RAID state. The RAID 6 implementation requires at least 4 disks. RAID 6 distributes the parity across all the disks. The RAID penal penalty in RAID 6 is more than the RAID 5. Therefore, RAID 5 writes the perform better than the RAID 6. The rebuild operation in RAID 6 may take longer than its RAID 5 due to presence of the two parity sets. Here we have used the two parity sets here. RAID impacts on application. When choosing a RAID type, it is imperative to consider its impacts on disk performance and application IOPS. The total disk load should be computed by considering the type of RAID configuration and the ratio of RAID compared to the write from the host. The following example is illustrate the method to compute the disk load in efficient type of RAID. Consider an application that generates 5200 IOPS with 6% of them being RAID. The disk load is in RAID 5 is calculated following RAID 5 disk load read plus write is zero point 0.6 into 5200 plus 4 into zero point 0.4 into 5200 because the write penalty for RAID 5 is 4. So at 3120 plus 4 into 2080, 3120 plus 8320, that is 11440 IOPS. That is impact on disk performance and application. The disk load in RAID 1 is calculated as follows. RAID 1 is disk load is 0.6 of 5200, that is 2 into 0.4, that is 5000, because very write manifest as 2 writes to the disk, that is for the RAID 1 is 7280 IOPS. For the computed disk load determines the number of disks required for the application. In the example, disk drives a specification of a maximum 180 IOPS need to be used. Number of disks required to meet the workload for the RAID configuration would be follows. RAID 5 is 11,400 440 divided by 180, that is 64 disks. RAID 1 is 7,280, that is 1 divided by 180, that is 42 disks, approximate to the nearest even the number. Intelligence storage system with the advance with advancement in technology, a new breed of storage solution known as intelligent storage system has evolved. These intelligent storage systems are a feature-rich RAID always that provides highly optimized I/O processing capability. These storage systems are configured with a large amount of memory called a cache and multiple I/O path and uses sophisticated algorithms to meet the requirements of the performance-sensitive applications. These arrays have an operating environment that intelligence and optimally handles the management, allocation, and utilization of the storage resources. Supports for the flash drives and other modern days technologies such as virtual storage provisioning and automated storage added a new dimension to the storage system performance, scalability, and availability. Computing components. Let's come to the components of an intelligent storage system. An intelligent storage system consisting of four key components: front end, cache, backend, and physical disk. Figure shown that illustrates the components and their interconnections. Host is connected with the connectivity to the storage area network that is connected to the intelligent storage systems. That is, you have the front end, cache, backend, and physical disk. It is controlled by the what's connected with the ports and front end controller and back end controllers, so on. An IO request received from the host at the front end port is proceed to the cache and backend and enable storage and retrieve data from the physical disk. Yeah, the front end end provides the interface between the storage system and the host. It's consisting of two components, front end and port and front end controllers. Typically, a front end has a redundant control for high availability, and each controller contains multiple ports of enable large number of hosts to connect to the intelligent storage system. Each front-end controller has a processing logic that executes the approximate transportation protocol such as fiber channels, ISC, SI, Picon, and SCOE for storage connections. Front-end controllers routine data to and from cache via the internal database. When the cache receiving the right data, the controller sends the acknowledgement message back to the host. Cache is a semiconductor memory where the data is placed temporarily to reduce the time required to service IO requests from the host. Cache improves the storage system performance by isolating hosts from the mechanical delays associated with the rotating disk or hard disk drives. The data access on a rotating disk usually takes several million seconds because of 6 time and rotational latency. Accessing data from the cache is the cost and typically takes less than a milliseconds on intelligent array writes data in a first place in cache and then return to disk. Structure of cache. Cache is organized into pages, which is the smallest unit of cache allocated. The size of cache page is configured according to the application of IO size. Cache consisting of database store and a tag RAM. The data store holds the data, whereas the tag RAM tracks the location of the data in the data stores and in the disk. This is what the cache memory and then the disk. This is what those are the tag of the RAM. Yeah, entries in the diagram indicates where the data is found in the cache and where the data belongs to the disk. The diagram includes a dirty big flag which indicates where the data is cache has been committed to the disk. It also contains the time-based information such as the time of last access. Read operation with the cache. When a host issues a read request, the whole storage controller reads the RAM to determine whether the request data is available in cache. Its requested data is found in the cache. It's called read cache hit and read hit and data is sent directly to the host without any disk operation. It is if the requested data is not found in the cache, is called as a cache miss, and the data must be read from the disk the back and access and approximate disk and retrieve the request data. Data is then placed in a cache and finally sent to the host through the front end cache misses, increasing the IO response time. Data found in cache read hit that host is read request that is sent to the cache, then the cache is retrieve the data from the disk physical disk that is within the cache. Its information is there and it's going to retrieve by the host. It's sent by the cache only. If its data is not in the cache, then the read miss that is comes to the read request, then cache is sent to the read request to the physical disk, then the physical from the physical disk it's read out from the it's sent to the cache memory, and then the cache is sent to the host. A prefetch or read ahead algorithm is used when the read requests are sequential. In a sequential read request, a continuous set of associated blocks is retrieved. Several other blocks that have not yet request to the host can be read from the disk and placed into the cache and advance. When the host subsequently requests these blocks, the read operation will be read hits. In an intelligent storage system offered fixed and variable prefetch size in the fixed prefetch, the intelligent storage system prefetch a fixed amount of data. It is most suitable when its host IO size and uniform. Write operation with cache. Write operation with a cache provide the performance advantages over the writing directly to the disk. When an IO is returned to the cache and acknowledge, it is completed in far less time from the host perspective, then it should take to the write directly to the disk. And write operation with the cache is implemented in the following ways. Write back cache and write through cache. Cache can be bypassed under the certain condition such as a large size write IO in the implementation. In the size of the IO request exceed the predefined size called write aside size. Writes are sent to the disk directly to reduce the impact of large writes consuming a large cache space. Thank you.